Okay, let's start. My name is Nicolas Roggenbauer. Hello, everyone. I'm from the Automatics team. I'm the managing director and co-founder together with Manuel. Manuel will take the live demo later on, and we're happy to be here today to present you really deep dives into the near zero downtime patch management and the patch management in general. And we make this webinar series together with Tricise, which are attendees in the chat as well. So if you have questions, feel free to ask them. And this webinar series is based on the partnership together with Tricise, because we know that all the maintenance activities in the SAP area is necessary to collaborate in between of the tools to align the needs of the business processes together with the technical processes. And as an introduction, we will switch now to our slides for a few minutes, where I guide you through the main points of this today's webinar, and then we will hand over to the live demo. Okay, yeah. So focus on the holistic SAP automation processes today, with the main focus on the downtime, near zero downtime patching operations. First of all, I would like to start with the part of how looks modern automation in hybrid SAP landscapes, and what is necessary to automate processes in this area. And as a next step, we give you a short overview about our Smart SecOps platform and the integrations we have out of the box in place, as well as the integration to Automic. And then I will hand over to Manuel for the patching scenarios for today's live demo. And then we will guide you through through our web application to give you really deep insights about how it feels, how it looks to manage database patches, OS patches, and kernel patches within our software. Yeah, four main points which are really relevant in this area. So the first one is that we like to address that it's necessary to have central applications in place which can consistently operate different workflows and different changes in the SAP system landscape, independent if it's only on-prem, if it's combined with an infrastructure as service environment within a private cloud workspace, or combined with a RISE offer or BTP landscape. So the most important point is to combine landscape operation models to each other, to combine different business processes to each other, and to get, as a first step, transparency into your system landscape. So we deliver centralized views of your system configurations, interfaces, about data exports, logs, and so on. And based on that, you are able to proactively maintain your system landscape. So, for example, to manage the patching of your systems, to implement SAP nodes, to renew and distribute certificates, to manage your system and client copy, pre and post copy activities. And for sure, in the future and for now, we are pushing as well the hybrid operation models with the RISE landscape in the private cloud workspace, and for sure as well for BTP, global account, sub-account management, to get all this necessary stuff in one environment. And yeah, automatics alone is good, but not all. So integration is really important as well with Automic to really get this necessity to manage different tools manually, to document in different tools, to log in different tools, to report out of different tools on a just manually way. So it's important to combine this via API calls, via ticket integration, to resend logs back to Automic, to get Automic workflows the possibility to create follow activities in automatics and so on. Yeah, as a next overview, I would like to show you our Smart SecOps platform. This is the product name of our platform, which includes 5 different hubs. I mentioned some points before. One important part is the Transparency Hub, which is the baseline to get insights into your system configurations, parameter settings, audit syslogs, BTP accounts, architecture of your system landscape, which is necessary for the patch mechanism as well, for cluster configurations. And we can align such configurations as well against the security baseline to set on the top of the standard recommendations from the community or from SAP, and reference this to your system configurations. And based on that, we have these automation hubs on the right side, beginning with the operation hub, which is handling all the on-prem patch management operation tasks, beginning with simple activities like start, stop, restart, up to the full stack patching operation, operating system database, and SAP components, as well for profile parameter management and HANA database parameter management. This will be the focus for today. And for sure, as you can see, there are different other hubs and activities which can be managed fully automatically with the integration to surrounding systems. About the integrations, I would like to highlight 4 different integrations we have standardized in place. First of them are the SAP portal, where we can integrate SAP maintenance planner information for the SAP nodes recommendations, that we can handle all the security patch day information and all nodes which results out of these findings with the related CV score and additional information. And as a second one, the download center integration, which is interesting for today, where we can identify where is a new patch file, a new patch level for different systems, and we can fully automatically download them for the patch operation process. We are a certified Red Hat partner for Ansible automation, so we can integrate playbooks into our software to make infrastructure changes quite easy for the integration to other automation scripts you already have in place. The Tricise Automic Action Pack, for sure, this is ready to deploy in your Automic environment. It's really easy to use. You have just low efforts to integrate this into the automatics platform, and you can easily trigger workflows and get information out of these tools in both directions. And the 4th point is more the organizational part, but it's quite important for all of our customers, that you can correlate this information as well in an ITSM solution or in a CM solution for the SOC, and to handle, for example, incidents or standard changes within this process fully automatically, and you do not have to make this on a manual process to trigger your own tickets. This can be handled via automatics as well. Yeah. Now to the focus topic of patching scenarios. Manuel will give you a short overview about the scenarios and the possibilities, and then we will start with our live demo.
Perfect. Yes, thank you. So just on one slide, a quick overview about how we understand patching from an automatics perspective. So basically, we see it in three different areas, three topics. One for the more application-related patching scenarios. Then we have the database patching scenarios, and on the operating system level. For application patching, Automatics delivers standardized, ready-to-use workflows to do patching for SAP kernel, host agent, diagnostic agent, and also even more inside the application, spam and sync updates. So add-on packages like SDBI and SDAPI, for example. On a database side, Automatics fully supports all databases known in the SAP area. So of course, SAP HANA, server patching, as well as client patching. We also have patching workflows for MaxDB and ASE, and also third-party database vendors like IBM with the DB2 database, Oracle, and Microsoft SQL Server. On operating system side, there are mainly two parts. One is Windows, one is Linux. For Windows, we can do OS updates with the basic Windows update, or also a lot of customers use SCCM, so centralized controlled patching for the Windows servers. On Linux, basically each package manager can be supported or can be addressed with Automatics. In the SAP area, it's mainly Zypper for SUSE-based operating systems, and DNF or YAM for Red Hat Linux. And all this patching is never standalone. So there are always dependencies. There are always other systems which needs to be integrated in patching processes. So for example, cluster managers, which can be a Windows failover cluster on the Windows side, a pacemaker on the Linux side, or any other cluster vendors. So there are some in place in the SAP area. So we can also integrate them into our patching processes to have near zero downtime patching, or to at least ensure that there is no interaction, no unwanted interaction between the Automatics patching process and any cluster software. And same applies to the infrastructure. So it's often seen at our customers that, for example, the hypervisor or hyperscaler is integrated for generating snapshots, for reverting snapshots. We also see backup integrations to several backup tools to make backup restore processes during the patching processes. Storage integration to NetApp, for example, is also often a topic at our customers. So all this infrastructure side integrations are very important to provide seamless patching processes of your SAP systems. Yeah, just some keywords are listed here on the right side. So what does Automatics bring on benefits to the patching process? We have out-of-the-box dependency management. So Automatics already knows the system dependencies between HANA databases, especially multi-tenant HANA databases to each SAP systems. We know dependencies with web dispatchers, with subrouters, etc. So all this landscape management is done out of the box within Automatics. We have several validations in place for pre-checks of patch workflows to make sure to guarantee a very high success rate in the real life runs. Yeah, things like built-in governance through approvals, so ticket approval steps can be implemented. Evidence collection, audit trails, all these are very important points down to at least the near zero downtime operations by integrating cluster and infrastructure stuff. And all-in-one maintenance windows. What this means is also shown in the live demo then. Yes, so I would switch to the live demo now. and hand over to Nicky again to make the first introduction. Later on, then I will go into the deeper technical things.
Sure. So what you show the total screen, I think.
Yes.
Yeah. So what you see here is our main dashboard, entry dashboard, in a modern web interface. So we have a state-of-the-art web application with responsive design, easy to handle, and you get out of this dashboard all necessary first information. So as mentioned before, we are able to discover the SAP system landscape fully automatically. You have here some insights about the component types, about the status of each entity, to get a quick look on the behavior of your system landscape. On the right side, you can see the KPIs of executions. At the end, the latest 10 executions with more details to really have a quick look on what is going on in your landscape at the moment. And in the left area, you get some security and compliance insights, which will be focused in a later webinar session, where you get really inputs about your compliance checks. And as told before, you have some administration possibilities, like to set up the discovery logic. We have the capability for a network scan for the subcontrol port and RFC scan to your SAP landscape, and get out of these informations really the complete landscape view. So on the left side, you see a tree. We are multi-tenant capable. So you can see per client your system list. And if you click on the system, you jump into the next layer for the application components or database components. And below you can see the server on which the component is running. And beside, you have several column informations, like an icon for virtual components or virtualized components, for the status of each component, the type. We are able to have different hosting platforms like RISE Private Cloud Edition and on-premises. You see the dependencies Manuel talked about before, that you know which system has an effect on another system or on a web dispatch or subroute or something like that, and some description and tag functionalities for your own clustering and documentation needs. If you open the detail page on the right, you have a graphic overview about your system architecture. So you see the components on each server, which is configured maybe as a standalone component or a clustered component with an active and passive node. You see when it's virtualized, you see if a pacemaker, for example, is behind this virtual host, and for sure you have behind cluster and status checks, which are updating this information on a recurring base. So on the right side, you see the HANA system replication or tenant replication with the active and passive tier. And this is below the graph, you see some details about each entity. For example, the installed SAP components with their version, SAP clients, and down to the operating system level, where you have further information about your operating system patch level, about the kernel for sure, database versions, and so on. So everything is given in this landscape, and this is the heart of automatics. Based on this information, we can manage all the patch activities with the dependency management, with the validations, to be sure that everything works fine in this automated process. And if you like, for example, to create a workflow for a kernel change, we have the centralized automation dashboard, where you can select based on all the ready-to-use functionalities the different workflows. Maybe we test it with the SAP kernel change. Select it, use a template if you like to use, and then you have a 3-step wizard for all these workflows. The first one is to select all the necessary systems you would like to perform in this workflow, and you have details about the systems which are relevant for the workflows, like in that case the technical information, where you can find the kernel version and patch level of each system. And based on that, if you continue with next, you get pre-assigned download center information. It's not the only possibility to provide these patch files. You can download it on your own, provide it via file share, via file upload, or you extract the files already and provide them. And since we would like to manage today the download center integration, you see in the below table all the possible SAR files which are newer than the current installed version. And for sure, you can use different system configurations, and Automatics is assigning the correct files with the correct system configuration. So in that case, we only have to filter on Unicode and get a complete clear list on all possible packages. And the only thing you have to do is to select these packages you would like to update in this kernel patch process. Scroll down to some configurations we provide. For sure, you can schedule this workflow just by adding a schedule and, for example, one time, and set a date time picker, for example, to this Saturday on 12 o'clock or something like that. And then you can continue with next. Everything is prepared. We make in this validation some configuration checks. If the systems are accessible for Automatics, we are checking some detailed behaviors, and everything is fine. We can finally schedule this. This makes it more sure that the automation process will be finished successfully at the end. And then after this configuration, you can execute, or in this case, you can schedule a workflow. And you have now this workflow in the schedule list where different other schedules are already in place with one-time or recurring work processes. And for sure, you can edit it once again. You can change the time. You can delete it if you can't make this kernel change in that time. And if we switch back to the execution tab, here you can see all the old executions with their status. So we did this kernel change 2 days before, and we can have a look into one of such executions. So it's quite straightforward. In the top, you have the execution information. So who has triggered this execution? When was it triggered? How long did the execution take? Which files were selected, and the configuration for this workflow. And if you minimize this upper part or to scroll down, you see really the detailed technical command line log outputs from this workflow. So each step, beginning with downloading the files up to the validation where we check manifest files to the current configuration of an SAP system, to be sure that it's a newer version, the production OS is correct, the compiled for is correct, and so on. And if this and the free space for sure. And if this is fine, we start with the real kernel change. Before we extract the files, we make a backup of the kernel directory. So we stay sure that if something went wrong with this patch process, you can roll back fully automatically to the old backup, or you can check and find the issue and manage the rollback manually. And after the kernel change, so it's a standard behavior with sub-car process, with running the subroot, sh script and ICM bind and so on. After finishing to updating the kernel directory, we can restart optionally this application components of the system to run the CPE and take over the kernel into the active system. And if you do like to split this process, for sure, if you have shorter maintenance windows, you can run this kernel change upfront without any impact to the running system and just make the restart in your maintenance window to keep the duration a bit shorter, so you can split it up. So this is one good example how easy it is to handle such patch processes. And Manuel will show you some insights about more complex configurations with cluster configurations, with combining different patch processes within our custom workflow engine.
Yes, thank you. Yeah, just before I go into the more complex and customizing things, here you see all the standardized or by standard available workflows that we provide. So what I've shown in the slides before, we have kernel change, we have database updates for all SAP related databases. We have this host agent, diagnostic agent update, support package and add-on update, etc. So very similar. It's always the same wizard to what Nicolas has shown before. This works for all these workflows. So for example, I can very quickly do an DB2 update by just going through this wizard with the download center integration and then starting or scheduling the update. But yeah, very often I cannot always use this very basic workflows since I have special setups. I have cluster configurations in place. I maybe want to integrate VMware snapshots, other stuff, or I want to combine workflows. For example, in a maintenance window on the weekend, I directly want to patch the HANA database, the HANA client, the operating systems, and the kernel just in one single workflow. So all this is possible in Automatics with our custom workflow engine. This can be found at the configuration custom workflows, and basically splits into two main areas. One is called tasks. So basically a task is the low-level step in an automation process. So in the end, this is a script which can be Bash, PowerShell, or also Ansible playbook. And this is available for different things. So you can fully create your own scripts, but we also provide templates from our side, from Automatics, which are good to use in a lot of scenarios, but which can be adopted to the customer's specific needs. So for example, for OS patching, we have tasks already. This is the wrong, sorry for this. I have to go here. In the practice guidelines, we have a lot of, almost ready to use tasks, which just need small adoptions in some cases, not in all cases. And then you can handle all the activities needed. For example, cluster related activities with maintenance mode or service IP related things. I just go through this very quickly. Interesting also is, for example, the whole OS patching things. So we provide templates for Linux patching, for Windows patching, with or without CCM, etc. Yeah, pacemaker related tasks, reboot of hosts, for example. Yeah, different tasks for SAP deployment also, for example, to set up systems, set up new systems. HANA system replication is a very important topic here. and finally down to the Windows failover cluster. So for all these integrations, there are templates available from our side which can be used. And these tasks are then combined together in custom workflows. So a workflow is a combination of tasks which can be created very easy. So let me quickly show you how to create the new custom workflow. I can call this Tricise webinar. I can choose an icon, I can give a description, I can categorize and group workflows, and I can select on which entity level I want to execute this workflow. So do I want to execute it for whole systems, for single components only, or maybe on a host or so on a node level? Let's say I want to do it for whole systems. And what I want to do is defined in the steps. And I can here make a combination of single tasks of other workflows, for example, altogether automatics provided steps and workflows, and also customized or customer created things. So I can, for example, say, let's make a kernel change from file share. And after the kernel change, let's do a HANA server update from a file share. And after that, even a HANA client update from a file share. So here I can really combine these automatics workflows into one single customized workflow. And then let's say I also want to do a snapshot. So I know there is a task for this where I can create a VMware snapshot. Not NetApp, VM snapshot create. And let's say, of course, it makes sense to do the snapshot on the first step. So I just can move this around here and say, okay, make the snapshot, make the kernel change, change the HANA server and also the HANA client. Now I can just save this workflow, and after that, it's immediately ready to use. So I can then go to automation, and beside the automatic standard workflows, I here have the tab for custom workflows. And now somewhere I have not added the group, and I have to reload the page once. I should then see the Tricise. I have disabled the section, sorry. So it's in the default section if I do not define a group. And now I see this Tricise webinar. And when I go into it, it's again the same wizard. I select the systems where I want to perform this workflow. Next, some configuration. Now a bit more, since it's a combination of a lot of stuff to do. But yeah, very easy to understand and to use in this wizard, and then I can directly execute. Yes, that's basically how the custom workflow mechanism, the custom workflow engine works in automatics. I just want to give you 2 or 3 more examples of what can be done and how does this look like, especially for zero downtime things. So I've prepared and executed some workflows. One, for example, is operating system patching for a high available NetWeaver system. Hard to say. In that case, with a non-clustered ERS, so the older setup, for newer setups, of course, the ERS is also clustered. This basically works the same. So this is just one of our test systems where we have this non-clustered ERS. And when I jump into this execution, I now see the whole process that's happening there. So at the beginning, automatics is collecting some information. This is not so interesting. Then the interesting part really starts here, where automatics stops the ERS. So the application server, this is a dual application server system where it stops the application server on the ERS node. This is done in a sub-workflow, so workflows can be cascaded, and I can directly jump into the logs and the execution details of this sub-workflow by clicking on it. And here I just see the instant stop of this application server with instance number 31. So this was stopped within this workflow. Yeah. Then once the ERS is stopped, then once the application server is stopped, in the next step, the ERS is stopped. Again, the same within a sub workflow. And then on this node, which now has no running ERP, no running SAP instance, the OS patching and the reboot is done. Maybe let's quickly look into the logs here. What this looks like, that you have an idea. Here is also some of the cluster stuff happening. So in this case, we choose the way to directly interact with the Windows failover cluster. There are often several methods how this can be done. For this execution, we suspended the cluster node and trained the roles. So we really make sure that there is no running cluster resource on this node. Yeah, looks just like this from the output. Then we ensure all cluster operations are finished, and then we directly do the OS patching and the reboot. So in this case, as you can see, some of you may know how Ansible output looks like. So this is an Ansible playbook for the OS patching. And in this case, one security intelligence update was installed on this Microsoft server. Yeah, then the host is rebooted and it is waited until it is online again. And after that, the Windows failover cluster is set to resume the node and fail back the roles. So it is back to the former operational state again. And now in the main workflow, once this has finished, the ERS and the application server are started again. This needs to be done separately since it is not part of the cluster. So there are no cluster roles for the application server and the ERS in that case. If the ERS is a clustered instance, which is more often the case in modern setups, then the stopping and starting is done during the cluster node standby. Yeah, and once everything is up again on this node, the same thing again happens on the other node. So the application server is stopped, and then the OS patching with this cluster suspend and resume is triggered, which then automatically moves the ASCS instance to the other node so that the system really is online all the time during this whole process. So this is really a zero downtime OS patching workflow, which Automatics fully handles automatically. Yeah, one more example for HANA patching with zero downtime with system replication setup. In this case, there is a pacemaker in place on this system, but we decided to not use the pacemaker for the switchover in that case, just for demonstration purposes. But we did the switchover directly with Automatics. So again, after collecting some information, here the main workflow starts. We just quickly check if everything is fine with the system replication. And then we start with HANA server patching on the secondary side. Just once again, a quick look into the HANA patching process. So here we have the whole log output of the HANA lifecycle management. So here really the HANA server component was patched. And then the operating system is patched on the secondary side. and then it is started again. And after the start, there is a HANA takeover is performed, which consists of several steps. Now with automatics really performing the takeover. So doing all the necessary commands like bringing down the service IP, stopping the tier, performing the takeover command itself, and bringing up the service IP on the other side so that the database is reachable again. And then the former primary node is now free of any relevant resources, and the HANA and OS patch can be done there. And after that, just to bring the HANA system replication setup fully online again, we register the former primary side as a secondary and start the database again. And finally, verify if everything is fine with the system replication. This is an example for a HANA database. And one last example how all this can be combined during the whole stack. So in this execution, we really did operating system, database, and database client and kernel patch in one single workflow. So also this is possible to combine it through the whole stack. Just very quick. It started with some validations, then the SAP components are stopped. So in this case, it is not zero downtime. This is a patching process with downtime, but it demonstrates how a maintenance window on the weekend during nights can be done without any manual interaction through the whole stack. So the components are stopped, then the HANA database server is patched. This again is a sub workflow. Then the HANA client is patched. So here we have the log output of the lifecycle manager patching the HANA client. Then we do the whole kernel change. A lot of log output here for the kernel change. And finally, we also do an operating system patch. As you can see, also a lot of S packages have been installed on this system, haven't been patched for a long time. And then basically we are done and we start. Also, a reboot can be added here. So in this case, we did not add the reboot, but it can be added at any time. And after the reboot, then all components and services can be started again. Yeah, this was one more example. Finally, before I finish my live demo, I just want to show you something from a very recent customer scenarios, since I really like this project at the customer side. No, not here. 1 second. I'm at workflows here. Where is it?
The second one, LG Automatics.
It's LG OS, I thought, but I can't find it. 1 second. Yeah. Oh, it's here at LG SAP. So I'm sorry for the German words. The customer is an Austrian customer, and he wanted everything in German, also the names and the descriptions. But what this means is update operating system for a HANA DB and the SAP system. And when I jump into this, we see how the customer provided this workflow, which steps the customer added to this workflow. This is a former SAP landscape management Llama customer. So he always does full unprepare and prepare of systems. So with removing all the mounts, removing all the virtual IP addresses, etc. So instead of a normal stop or start, here we always talk about unprepare and prepare. And what's also interesting here is the VMware snapshot integration. So before the OS update is done, a snapshot is created. And after the snapshot, there is another integration to VMware to upgrade the virtual machines hardware. So this is also done directly during this process. If there is a newer VM hardware version for this this virtual machine, this is also deployed at this point. And also very interesting for this customer, it was very important to have a safety mechanism, especially for production systems. If something is wrong or something goes wrong during the operating system update, for example, or if the system is not coming up again after the update, that there is always a quick way back and an automatic way back. So they trigger or they schedule the production updates during the nights at 1, 2 o'clock in the morning. And if something goes wrong, there is an error handler defined. So this is also possible, which basically, reverts the snapshot and then prepares the system again. So that if something goes wrong in the morning, the system is back online again with the old state. And then the SAP Basis administrators can go through the logs and check out what's going wrong, correct maybe the things relevant, and then trigger this update again for the next day. Okay. Then let's quickly go back. Sorry. No, I have ended the screen share. 1 second.